In this video, we're going to take a closer look at the design. We'll examine the various components, look at how they interact with each other, and how data is passed around the system. A big part of the exercise is actually marshalling data through different forms. So, for example, what starts off as a field in the Shotgun database becomes a Python dictionary. We then convert it into a C++ class hierarchy, and eventually we extract it into menu items and UI actions in Unreal. Here we are on the tasks page of Shotgun, and we can see that each task has a name, a link to the underlying asset, pipeline step, various assignees, and very importantly, ID. As we move into Python, everything becomes a dictionary. So key to their API is the notion of an entity that has a type and an ID. I've kept the same idea in the C++ model. Here's our base class, Shotgun entity, with ID and name, and our various subclasses. Shotgun task is the main aggregate subclass in that it keeps references to Shotgun asset and of course all of the assignees in the form of users. Same thing in the code, Shotgun task extending Shotgun entity. We've got a vector of shared pointers as our assignees. There's our asset, and the pipeline steps are simply a string. We wrap all of that up into maps, nested maps as it turns out, and then we drive the menus from there. So here again, pipeline step, task name, and users. So the same data flowing through the system, all we're really doing is changing its form. Back in the sequence diagram, and our main players are Shotgun utils.py, our C++ static library, and of course the plugin. Shotgun connection is the main interface between the C++ side and the Python side. It's responsible for making the Python calls and interpreting the results. We'll store everything in a repository. That'll be our Shotgun entity C++ hierarchy. The plugin keeps a reference to the Shotgun connection, which keeps a reference to the repository. As the plugin starts to load, we call onWorldCreatorDelegate, and that loads all users and loads all task templates. We do that at this stage because this data is unlikely to change. They both work in exactly the same way. Here's our Python call. The database comes back. There's the Python dictionary. We wrap that up into our Shotgun entities and we store it in the repository. Exactly the same thing for the task templates. Next up, we want to examine the scene, the level, and find all actors that are already tracked by Shotgun. If they're already tracked, they'll have a uShotgun data component attached to them. That'll have the ID we saw earlier. And what we'll do with that ID is we'll call all tasks for asset with it. There's our Python call, the database is coming back, translation, adding to the repository. So that's the loading phase, and we're now ready to start dealing with the users. If we right-click on an actor that is tracked by Shotgun, we'll want to call build task assign menus. That in turn calls get case users and get all tasks for asset. Now this data is coming from the repository that we loaded earlier. We don't want to make live calls to Shotgun every time a user clicks on an actor. Now we do have potentially stale data here. There's no way of locking the underlying database, and nor would we necessarily want to. Later on I'll go through some potential solutions involving queued requests, disparity checks between the model and the database, listeners, that type of thing. But for now we'll just assume the data doesn't change underneath us. There's that data coming back, and we'll fill the nested submenus from here. That's these guys, pipeline step, task name, and of course user. As the user clicks on a task and an assignee, we'll make the C++ call, assign task to user. There's the Python call. And at the moment, we're not actually validating the Shotgun response. We should. There's various ways it could fail. But for the moment, we're assuming a success, and we're updating the model by adding a shared pointer to the assignees. And if the user clicks on an actor that isn't tracked by Shotgun, we'll want to expose the create asset with task template option. There's the Python call, and this time we are validating the response. Shotgun just made an asset, and it returned to us the new asset ID. We wrap that in a Shotgun data component and store it in the actor in the level. That's really important because then in future, the plugin knows that the actor is tracked, and we can assign users and tasks from there. At the same time, Shotgun just created a series of tasks for that asset and attached them to it, so we'll make one more live call and update the model in the usual way. So that's the high-level overview of how all the various components interact. Next up, we'll look at the code.